Hello everyone. In this video, we'll see the components of image processing system. This is the pictorial representation of the components of an image processing system, which consists of problem domain, image sensors, then you have specialized image processing hardware, computer, mass storage, image processing software, image displays, and the hard copy. So problem domain can be in various forms. It may be like identifying an object, or it may be recognizing a face. Uh, there may be a variety of problem domains. Coming to the image sensors, here there are two elements which are required in order to acquire the image. First is the physical device and second is the digitizer. So here the physical device, it is sensitive to the energy radiated by the object we wish to image, and digitizer is a device for converting the output of the physical sensing device into the digital form. So here whatever will be the output of the physical device, if it is not in the digital form, then it will be converted to the digital form by using the digitizer. For example, you have a digital video camera. Here it consists of the sensors and the digitizer. So sensors will produce the electrical output, and which is proportional to the light intensity, and the digitizer, it converts the outputs to the digital data. Then next is the specialized image processing hardware, which consists of the digitizer and the hardware which performs the other primitive operations such as ALU, and this ALU, it performs the logical operations in parallel on entire images. For example, the ALU, it is used for reducing the noise when the image is digitized. That is, ALU, it is used in averaging the images very quickly as they are digitized for the purpose of noise reduction. And this type of hardware, it is sometimes called as the front end subsystem, and the most distinguishing characteristic is the speed. Therefore, this unit, it performs the functions which require fast data throughputs that the typical main computer cannot handle. And example for this is digitizing and averaging video images at 30 frames per second. Next comes the computer. So computer in an image processing system, it may be a general purpose computer, or it may be super computers. And sometimes the computers are customized, in order to achieve a required level of performance. The general purpose computers, these are used for personal work, and the supercomputers are used for scientific and research applications. And there are some specially designed computers also which are used for some specific task. Then you have software for image processing, which consists of the specialized models which will perform the specific task. And you have a well-designed package also, which includes the capability for the user in order to write the code, and it uses the specialized modules. And you have more sophisticated software packages, and these allows the integration of the modules and the general purpose software commands from at least one computer language, and you can store the codes and the programs also. Next comes the mass storage. Mass storage, it is must and it is very important in image processing system. Suppose you have an image with a size 1024 into 1024 pixels, in which the intensity of each pixel is 8-bit quantity, and it requires 1 megabyte of storage space if the image is not compressed. So here there are three categories of the digital storage for image processing applications. First one is the short-term storage, which is used during the processing of the image. Second is the online storage, which is it is for relatively fast recall, and archival storage, that is characterized by infrequent access. So storage is measured in bytes, kilobytes, megabytes, gigabytes, and terabytes. The short-term storage, it is one method of providing the short-term storage is the computer memory, and also you can like provide the short-term memory storage in terms of frame buffers. So this is also used for short-term storage. So you can use the computer memory as well as the frame buffers for short-term storage. And here it can store in frame buffers. These can store one or more images, and these can be accessed rapidly at the video rates 30 complete images per second. So here the frame buffers, these will allow the image zooming, that is virtually instantaneous image zoom is allowed here. Then you have it allows scrolling, that is the vertical shifts, and pan, that is the horizontal shifts. And the frame buffers are housed in the specialized image processing hardware unit. Then you have online storage. So the online storage, it generally takes the form of the magnetic disk or the optical media storage. And the key factor which characterize the online storage is frequent access to stored data. Then comes the archival storage, where it is characterized by massive storage requirements, but infrequent need for access. And here the magnetic tapes and the optical disc, these are housed in the jukeboxes, and these are the usual media for archival applications. Then comes the image displays. Mainly here we use the color TV monitors, and these monitors are driven by the outputs of the image and the graphic display cards that are the integral part of the computer system. Then some requirements for image display applications, these cannot be met by the graphic display cards which are available commercially as part of the computer systems. So in some cases it is necessary to use the stereo displays, and these are implemented in the form of the headgear, which consists of two small displays embedded in the goggles, which will be worn by the user. Then you have hard copy devices for recording the images, which includes the laser printers. Then you have film cameras. Then you have heat sensitive devices like inkjet units, and digital units such as optical and CD-ROM disk. For presentation for presentations, the images can be displayed on film transparencies, and or in a digital medium if the image projection like the image projection equipment. Then comes the networking. Networking, it is a default function in any computer system which is used today, and because of the large amount of data which is present in the image processing applications, the key consideration in image transmission is the bandwidth. So this was about the components of the image processing system. Thank you.